Welcome to video number 5. So today we're going to learn more about the implicit differentiation, and then we're going to learn about a new concept called L'Hopital's rule. All right, so these are just 4 important derivatives from the last video that you should remember. And these are the derivative rules that you learned from video 3. So these are also useful, so remember them. And to jog your memory of implicit differentiation, I'm going to show you an example of a problem that you can solve with implicit differentiation. So you're trying to find the derivative of x to the power of n. So to do that, the first step is to take the natural log on both sides of f of x equals x to the power of n. All right, and then remember that when you're trying to find the derivative of a function with an exponent, the first step is almost always to take the natural log on both sides, and that allows you to bring the exponent to the front. Okay, and then now differentiate both sides of the equation. So for the left side, just use the chain rule. So the inside function is f of x and the outside function is ln x. All right, the chain rule. So the derivative of ln x is 1 over x, and you replace x with the inside function f of x. All right, and then times the derivative of the inside function, and that's just f prime of x. And on the right side, it's just a constant times ln x. So the derivative is just the constant times 1 over x. Okay, and then now you want to isolate f prime of x. So multiply both sides by f of x. And you know that f of x is x to the power of n, so you plug that in. Okay, and then simplify. So f prime of x is equal to n times x to the power of n minus 1. And that is the derivative of x to the power of n. All right, so now we're going to get into the derivatives of inverse functions. But before we do that, we need to solve for the derivative of tangent of x. So if you want, go ahead and pause the video right here and try to find the derivative yourself. But anyway, the solution is, so tangent of x is sine of x over cosine of x. And then you use the quotient rule. So f of x is sine of x, and then g of x is cosine of x. All right, so f prime of x first, which is cosine of x, times g of x, and that's cosine of x, minus f of x, which is sine of x, times g prime of x, which is negative sine of x, and then all over g of x squared, and that's just cosine squared of x. All right, and then simplifying, we get that the numerator is cosine squared of x plus sine squared of x. And then using the Pythagorean identity, the numerator just becomes 1. All right, and then now we're getting into the derivative of inverse functions. So starting with the derivative of arctangent of x, which is just the inverse tangent of x. So what is the derivative? Well, the first step is to take tangent on both sides. And on the right side, tangent and the inverse tangent cancel each other out, leaving you with just x. And on the left side, we have tangent of f of x. And then now we differentiate both sides of the equation. Okay, so on the left side, we use the chain rule. So the inside function is f of x, the outside function is tangent of x. And we just seen that the derivative of tangent of x is 1 over cosine squared of x, and we replace the x with f of x, and then times f prime of x. And on the right side, the derivative of x is just 1. Okay, and so now we multiply both sides by cosine squared of f of x to isolate f prime of x. And then we plug in f of x equals arctangent of x. And I moved the squared outside, and you'll see why right now. Okay, so we want to simplify cosine of arctangent of x because that's a really complicated expression. So the way to do that is to draw a right triangle with one of the angles being arctangent of x. And then now, because this angle is arctangent of x, we know that the ratio of the opposite side over the adjacent side has to be x. And so the simplest way to do that would be x and 1. And then from the Pythagorean theorem, we know that the hypotenuse is the square root of 1 plus x squared. All right, and then we want to find cosine of arctangent of x. So cosine of this angle right over here is just adjacent over hypotenuse. That's 1 over the square root of 1 plus x squared. All right, so we got this, and then so we plug it in, and then all of this squared is just 1 over 1 plus x squared, and that is the derivative of arctangent of x. All right, so now if you want, pause the video and try this problem by yourself. All right, so the answer is, so we first take sine on both sides in order to get rid of the arc sine on the right, and then differentiate both sides of the equation. Okay, so use the chain rule on the left side. So the inside function is f of x, the outside function is sine of x. The derivative of sine of x is cosine of x, and you replace the x with f of x. All right, and then times f prime of x. And on the right side, the derivative of x is just 1. Okay, and then to simplify, or you multiply both sides by cosine of f of x, or actually you divide it. So then you get this, and then you plug in f of x equals arc sine of x. All right, and you draw the right triangle. So, whoops. All right, so this angle right over here is arc sine of x. All right, and you know that the ratio of the opposite over the hypotenuse is x. All right, and then this leg right over here from the Pythagorean theorem is the square root of 1 minus x squared. And you want to find cosine of this angle, and that's just the adjacent over the hypotenuse, which is the square root of 1 minus x squared over 1, which is just the square root of 1 minus x squared. All right, and then now we determine this right over here. We plug that in. And then the derivative of arc sine of x is just 1 over the square root of 1 minus x squared. All right, and now if you want, pause and try this problem by yourself. The answer is, first you take cosine on both sides and differentiate both sides of the equation. All right, and you just use the chain rule to differentiate the left side. Okay, and then you draw, so first you divide both sides by negative sine of f of x, and then you plug in f of x equals arc cosine of x. So you draw this triangle right over here. This angle is arc cosine of x. All right, and then you set up the sides of the triangle. And then this side right over here, you can determine that it's equal to the square root of 1 minus x squared. All right, and then sine of this angle right over here is just the square root of 1 minus x squared. All right, so we determine this value right over here. So we plug that in, and we get that the derivative of arc cosine of x is negative 1 over the square root of 1 minus x squared. All right, so now this problem is a little bit different. It's not a function. This is actually a graph of a circle with radius 1 centered at the origin. But can you, if you want, go ahead and pause this video and try this problem. All right, the answer is, so first you think of y as f of x, and you're trying to solve for f prime of x. That's the derivative. So you take the derivative of both sides, and then so the derivative of x squared is just 2x, plus use the chain rule for this. So you get 2 times x, but then since the inside function is f of x, you plug that in, and then times f prime of x. And on the right side, the derivative of 1 is just 0. All right, and then you want to isolate f prime of x. So you get this. And then now the 2 on the numerator and the denominator cancel each other out. And usually at the end, you plug in f of x is equal to y again. All right, so now this problem was a little bit different, but now the thing that you should take away from this problem is that sometimes with implicit differentiation, the derivative does not only need to be in terms of x, it can also be in terms of y. All right, so overall implicit differentiation can be used to differentiate exponential functions, inverse functions, and non-functions. So here are some examples. And now we're getting into L'Hopital's rule. So first of all, these are some indeterminate forms of limits. All right, so you don't know what these are. These can be many values. All right, so L'Hopital's rule states that if f of a over g of a is of the form 0 over 0, infinity over infinity, or negative infinity over infinity, then the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x over g prime of x. All right, so here's an example. The limit as x approaches 0 of sine of x over x. So first we need to plug in 0 for x to verify that the limit is of indeterminate form. If it's not, then you cannot use L'Hopital's rule. So you plug in x equals 0 and you get 0 divided by 0. So that is indeterminate, so you can use L'Hopital's rule. All right, so take the numerator of the numerator, take the derivative of the numerator and the denominator. So the derivative of sine of x is cosine of x, the derivative of x is 1, and now you can plug in x equals 0, and then you get cosine of 0, which is 1. So this limit right over here is equal to 1. All right, so now if you want, pause the video and try this problem by yourself. The answer. So first you verify that the limit is of indeterminate form by plugging in 0 for x, and you get 0 divided by 0, that is indeterminate. Take the derivative of the numerator and denominator. So in the numerator you get sine of x, and the denominator you get cosine of x. All right, so now you can plug in 0 for x, you get sine of 0 over cosine of 0, which is 0 over 1, and that's 0. So this limit right over here is equal to 0. All right, so now here's another practice problem. And this is actually a problem on the AP Calculus AB exam. Okay, so the answer, so first you need to plug in 0 for x to make sure that the limit is of indeterminate form. Take the derivative of the numerator and the denominator. So the numerator is pretty straightforward. And for the denominator, for sine of 3x, you use the chain rule, with the inside function being 3x and the outside function being sine of x. All right, and then now after you take the derivative of the numerator and denominator, you can plug in 0 for x. And you'll get 7 minus 1 over 3 times 1, because cosine of 0 is just 1. All right, and then the final answer is 2. So that is B. All right, here's another practice problem. All right, so the answer is first you verify that the limits of indeterminate form. So you plug in infinity for x, you'll get infinity over infinity, which is indeterminate. All right, you take the derivative of the numerator and the denominator. So the derivative of x squared is 2x. The derivative of 2 to the power of x is ln 2 times 2 to the power of x. And now you plug in infinity for x, and you see that you'll still get infinity over infinity. So it's still of indeterminate form, so you can use L'Hopital's rule again. All right, so you differentiate both the numerator and denominator. The derivative of 2x is just 2, and the derivative of 2 to the power of x is ln 2 times 2 to the power of x, and you still have a constant right over here. Okay, and then now you plug in infinity for x, you'll get 2 divided by infinity, which is 0. So the key takeaway from this problem is that for some problems, you need to use L'Hopital's rule 2 or more times to get the solution. All right, so now we've covered 2 indeterminate forms from the list, and here are some other indeterminate forms. So first of all, this problem is of the form 0 times negative infinity. If you plug in 0, you'll get 0 for x times ln of 0, which is negative infinity. And now 0 times negative infinity is basically the same as 0 times infinity. So to solve this, we need to turn it into fractions so we can use the L'Hopital's rule. Okay, so the way you do this is you just put x into the denominator. So x times ln of x is the same as ln x over 1 over x. All right, and then now you plug in 0 for x to make sure it's of indeterminate form. So ln of 0 over 1 over x, ln of 0 is negative infinity, 1 over x is infinity. It's indeterminate, so we can use L'Hopital's rule. So you differentiate both the numerator and the denominator, with the numerator being ln x and the denominator being 1 over x. All right, so the derivative of ln x is 1 over x. The derivative of 1 over x is negative 1 over x squared. And you simplify to get negative x. And now you can plug in 0 for x. So the final answer is 0. All right, so the key takeaway is if you want to find the limit of like a product of two functions, you turn it into this. So g of x over 1 over f of x, and try to use L'Hopital's rule for that. All right, so here's a practice problem. And if you want, then try this problem by yourself. The answer. So first you turn it into a fraction. So it's just ln of 1 plus 1 over x over 1 over x. And then you verify it's of indeterminate form by plugging in 0 for x. So 1 over 0 is infinity. And then you'll get infinity over infinity, which is indeterminate. All right. So you differentiate both the numerator and the denominator. And then, so for the numerator, you'll use the chain rule. So the derivative of ln x is 1 over x, and you replace x with the inside function. And the derivative of 1 plus 1 over x is just negative 1 over x squared. And the derivative of 1 over x in the denominator is also negative 1 over x squared. So these two terms cancel each other out. And then you're left with just this. And then now you can plug in 0 for x. So you'll get 1 over 0, which is infinity. So you'll get 1 over infinity, and that is equal to 0. So now here's another practice problem. And this one is a little bit more difficult. So I'll tell you the first step. The first step is to convert from from degrees to radians. So 180 over x degrees is the same as pi over x radians. And remember, in calculus, you always use radians. The reason is because if you don't use radians, then the derivative of sine of x would not be cosine of x, and the derivative of cosine of x would not be sine of x. All right, so now if you want, then pause the video right over here and try to solve this problem. The answer is, so you move the x over to the denominator. So this is the same as sine of pi over x over 1 over x. And then you plug in infinity for x to verify that the limit is of indeterminate form. You'll get 0 divided by 0, which is indeterminate. And then now you use L'Hopital's rule. So you differentiate the numerator and the denominator. So for the numerator, you use the chain rule, and you'll get cosine of pi over x times negative pi over x squared. And then the denominator, so the derivative of 1 over x is negative 1 over x squared. All right, so these cancel each other out, leaving you with only pi. All right, so then now you can plug in infinity for x. So cosine of pi over infinity, that's just 0. And cosine of 0 is 1. So you get 1 times pi, and the final answer is pi. All right, so this is a summary. So this is L'Hopital's rule right over here. You could just take the derivative of the numerator and the denominator. And then, so for some problems, you need to use L'Hopital's rule multiple times. And then to find the limit of a product of two functions, you turn it into this, and then try to use L'Hopital's rule. In the next video, you'll learn how to solve the remaining indeterminate forms. And the next video is video 6, so we're almost halfway through. But anyway, I'll see you all in video number 6.